Hi, this is Kodanda Ramaiah, for Assistant Professor of Department of Mathematics. Last class I have discussing with the linear differential equation for RHS term equals to constant. So many methods and so many different kinds of things we have to find out for that linear differential equation. So last class, how to find out the linear solutions of linear differential equation. So the general solution of linear differential equation with second and higher order of differential equation is y equals to yc plus yp. So that means complementary function plus particular integration. So you know how to find the complementary function. What are the rules of the complementary function? I have discussing with the last class. So now today discussing with RHS term equals to e power ax or e power minus ax. So the RHS term, exponential function, where a is a real constant. So what is the particular integration of this type of differential equation? So last class I have discussing as usual procedure of complementary function. Complementary function is depending upon RHS term of the given function. Particular integration is depending upon RHS term. So the RHS term equals to e power ax. That means exponential function. So you can see the problem. The RHS term equals to exponential function. So that one is known as a linear differential equation of second and higher order of differential equation with the exponential function e power ax or e power minus ax. Complementary function is generally LHS term of the given problem. Particular integration is RHS term of the given problem. So the RHS term equals to e power ax. How to find out particular integration? So particular integration equals to 1 by f of d into e power ax. So 1 by f of d into e power ax, we have to replace d equals to a for the denominator term. So that one, the case f of a not equals to 0. So on that time, we have to substitute directly and simplify that one. We get a particular integration. In case f of a equals to 0, sometimes the denominator d replacing with a, the denominator term will be 0. So on that time, how to find out particular integration? So on that time, particular integration is x into 1 by f dash of d into e power ax. So now we can multiply x in numerator for given term and derivative for the denominator term. So that one is x into 1 by f dash of a e power ax. Again, f dash of d replacing with the a. So again, f dash of a not equals to 0, on the time this condition is right. In case f dash of a equals to 0, on the time the particular integration is 1 more x will be multiplied in numerator and again derivative for the denominator into e power ax. That one can be written as f double dash of a not equals to 0. This process will go to the and so on term. So one of the example of we can take that method. So now we can see the problem. Solve the differential equation d square y by dx square minus 2 into dy by dx plus 10y equals to e power 2x. So now we can see the RHS term e power 2x. So e power 2x means exponential function. So that's why you can find out the general solution of this equation is y equals to yc plus yp. So that means particular integration. So the auxiliary equation is m square minus 2m plus 10 equals to 0. Now we can simplify this one. We get the roots m equals to 1 plus or minus 3i. So now we can use the formula minus b plus or minus root of b square minus 4ac by 2a. Can substitute that values of in this equation. We can simplify that one. M equals to 1 plus or minus 3i. So this is in the form of alpha plus or minus I beta. So alpha plus or minus I beta means complementary function is e power alpha x into c1 cos beta x plus c2 sin beta x. So here alpha replacing with 1, beta replacing with 3. So that one can be written as e power x into c1 cos 3x plus c2 sin 3x. This is the complementary function of that given problem. And next we can find out particular integration. So the particular integration equals to 1 by f of d into f of x. So f of x means RHS term. What is the RHS term here? E power ax. So that one can be replacing as 1 by f of d into e power 2x. F of d means d square minus 2d plus 10. So d replacing with 2 here. So that one can be written as 1 by 2 square minus 2 into 2 plus 10. So that equals to e power 2x equals to 1 by 10 into e power 2x is a particular integration. So therefore, the general solution is y equals to complementary function plus particular integration. So y equals to complementary function means e power x into c1 cos 3x plus c2 sin 3x. So e power x into c1 cos 3x plus c2 sin 3x plus particular integration 1 by 10 into e power 2x. So e power 2x by 10. So this is the one of the method of linear differential equation with the second and higher order of differential equation with RHS term equals to e power ax. So the another method of the this linear differential equation for the RHS term equals to sin ax or cos ax. So the RHS term means every problem can depending upon LHS term equals to RHS term. So the second and higher order differential equation RHS term equals to trigonometric function for only sin ax or cos ax. Only these two trigonometric functions where a is a real constant. So for this method, the previous method, exponential method means put d equals to a here, put d equals to 2. For this trigonometric method, put d square equals to minus of a square. That is a particular integration. So d square equals to minus of a square. So the operate on this number term by term by taking d equals to d by dx. In case the denominator term f of minus a square equals to 0, and that time we can follow the formula particular integration x into sin ax by 2a for a trigonometric function of sin ax or cos of ax plus b. That means f dash of minus a square equals to 0. So again, this process will be until going on to the up to the denominator term not equals to 0. Right. One of the method, one of the problem, we can take the example of this one. Solve the differential equation d square plus d minus 2 into y equals to sin x. So this is clearly RHS term is a trigonometric function sin x. So now we can see verify this is in the form of sin ax. So a replacing with x here. So first you can find out complementary function. How to find out complementary function? You know everybody how to find out complementary function. Complementary function always depending upon the LHS term of the given problem. So the auxiliary equation is m square plus m minus 2 equals to 0. This equation by using find the roots. By using the roots of this one, either factorization method or minus b plus or minus root of b square minus 4ac by 2a. So that one can be written as m plus 2 into m minus 1 equals to 0. M equals to minus 2 comma minus 1. By these are the two real roots and distinct. So by using these roots, the complementary function c1 e power minus 2x plus c2 e power x. And next, you can find out particular integration that equals to 1 by f of d into capital F of x. F of x means RHS term of the given function. So that one can be written as 1 by f of d into sin x. So that equals to 1 by d square plus d minus 2 into sin x. So this is a method, trigonometric function means put d square equals to minus of a square. That one can be written as minus 1. So now d square replacing with minus 1 for this function. 1 by d square means minus 1 plus d minus 2 into sin x. So 1 by d minus 3 into sin x. After substituting d square value, again the denominator term depending upon derivative term. So in our, we can eliminating the derivative term of the denominator. So we can apply a rationalization for the denominator term. That is 1 by d minus 3 into d plus 3 by d plus 3 into sin x. So d plus 3 into sin x by the denominator term is d plus 3 into d minus 3. That one can be written as d square minus 3 square. So that means 3 square means minus 9. So that equals to d plus 3 into sine x by minus 10. Again, put d square equals to minus 1. So that one can be written as the simplification of the numerator term. Minus 1 by 10 into derivative of sine x plus 3 into sine x. The derivative of sine x is cos x. So that one can be written as minus 1 by 10 into cos x plus 3 sine x. So this is a particular integration for the RHS term equals to sine trigonometric function. So therefore, the general solution y equals to complementary function plus particular integration. So y equals to complementary function is c1 e power minus 2x plus c2 e power x. Particular integration is minus 1 by 10 into cos x plus 3 sin x. The sum of complementary function plus particular integration, that equals to y equals to c1 e power minus 2x plus c2 e power x minus 1 by 10 into cos x plus 3 sin x. This is a required general solution for the linear differential equation with RHS term equals to trigonometric function.